The solution to systems of inequalities is often an infinite number of ordered pairs, and so rather than try listing such things, we just express the answer as graphs. I'll show you how to graph this one linear inequality, and graphing a system is just a matter of doing it twice, or maybe 3 times. I'm going to do this one by hand, and if you feel more comfortable using your calculator, you're certainly welcome to. If I take a look at the equation, which is, notice, the same as this, but with an equal sign, I can use what's called the intercept method. If I take the 12 and divide by -4, 12 divided by -4, I get -3. Now -3 is the x-intercept. I can put a dot at -3 on the x-axis. If I divide the 12 by -3, I get -4. Now that is the y-intercept. So I put a dot at -4 on the y-axis. Now back to the inequality. If the symbol, the inequality symbol, has the line under it, then we construct a solid line through the 2 dots. Now if that had been a less than or greater than without the equals on it, we would have constructed a dashed line. And then we decide which side to shade. To do that, we pick a point that is obviously on one side or the other. It doesn't matter what point as long as you're certain which side it's on and you know its coordinates. I am particularly fond of this point, 0, 0. If I take the original inequality and substitute a 0 for x and a 0 for y, I get 0 minus 0, which is 0. And the original inequality said 0 is greater than 12. That is not true. Therefore, the opposite side of the line needs to be shaded. In the My Math Lab homework, you'll have to see how to do that. You have a little paint bucket to use, and you just point at the region you want to paint and click it. So, one more time, I'm going to divide 6 by 3. That's the x-intercept. I'm going to divide 6 by -2. And that's the y-intercept. I'm going to draw a dashed line between those 2 dots. And do the same thing as before. Pick out a point and test it. As you just saw, I am particularly fond of 0, 0. So 3 times 0 minus 2 times 0 is 0. Is 0 less than 6? Yes, it is. So we need to shade this part of the graph. Now this one's a little bit more challenging for the graphing, and again, if you need your graphing calculator, then you can draw the graphs on those. I'll color code these for you, starting with the top one in red. The parabola y equals 4 minus x squared is going to have a dot at 4, and it's going to open downward, and it will be dashed. and the graph of x equals y minus 1. If I move the 1 over to the other side, that would be y equals x plus 1. Using the slope-intercept method, this has a y-intercept of 1, that would be here, and a slope of 1. So from that dot, we would count up 1 and over 1. And it likewise is a dashed line. Now again, the dashed line just means that is not part of the solution. And so now, you notice, we have several options. We can shade up here, which is above both graphs. We can shade down here, which is below both graphs. We can shade over here, which is below the blue graph and above the red. We can shade out here, which is also below the blue graph and above the red. Or we can shade the part in between those. As before, we pick us out a point and give it a try. Now, suspecting this is going to be sort of a normal sort of situation, I'm going to pick out a point inside of both of them, because that would be the cutest looking graph. And I'm going to give it a try. Now that point is 0, 2. So if I take the first inequality, use a 2 for y, then 2 is less than 4 is true. Now here's the deal. It's got to work in both of them. So in the second one, we've got 0 for x, 2 for y, and 0 less than 1 is likewise true. So as I suspected, it is the part that's in between both of those.